Hello everyone. In this video we will learn about concept of process. First of all, what is process? You might have seen this screen in first semester during CPU lab. You have written program in C language in some editors like Turbo C or some other editor. So this is screen of Turbo C editor. Here we have written a program to print hello world. Now once we complete this program, now next step is to run this program. Now if we want to run this program, then what we will do, we will click on run. Under run there is option run, or you can press Ctrl F9 to run this program. So once we run this program, we got output like hello world. Here once we run this program, then it becomes a process. So we can say that process is a program under execution. Means once we run any program, it becomes process. We can also say that process is an abstraction of a running program. Process is an instance of an executing program, including the current value of program counter, registers and variables. So these are the different definitions of a process. Now each process has its own virtual CPU. What does it mean? It means that in each and every computer there is only one physical computer, but it supports multi-programming. That means execution of more than one program or more than one task at a same time. So whenever more than one process are executed in a computer, in that case that each process has its own virtual CPU, means it creates more than one virtual CPU, and each virtual CPU is allocated to each process that will execute that process. So each process has its own virtual CPU that will execute that process. Next, move further to multiprogramming. What actually multiprogramming is? Multiprogramming is an ability of computer that execute more than one program at the same time. Let's consider, suppose in this figure, this user is performing two tasks. First task is listening songs in some media player, and second one is typing documents in Word. So here this user is performing more than one task at the same time. This is nothing but a multiprogramming. But in real, there is only one physical CPU, so at a particular time only one process is executed, but that CPU switches back from one process, that is from Word to media player, again media player to Word, again Word to media player. The real CPU switches back and forth from one process to another process, and that rapid switching back and forth is too fast that we cannot identify it. That is known as multiprogramming. So here our real CPU, that is our physical CPU, physical processor, is switches from this Winamp or media player to Word, again Word to media player, again media player to Word, and that is so fast that we cannot identify. And the rapid switching of your processor from one process to another process is known as multiprogramming. Here the number of processes that are loaded into our memory at the same time or simultaneously is known as degree of multiprogramming. Now how multiprogramming execution takes place? Here let us consider these are the three processes P1, P2 and P3. There is only one physical processor or CPU, that is a processor. Each process has its own logical program counter into a memory, and there is one physical program counter into a processor. Now whenever any process is executed, the content of this process is to be executed into physical program counter. Then and only then that process can be executed. So initially this processor is free, means this processor is not allocated to any of these processes. Now first of all, this processor is allocated to process P1. So during that time, what's happened? The content of this process, that is of P1's logical program counter content, is copied into physical program counter. Initially the physical program counter was empty, but once this processor is allocated to process P1, the content of logical program counter of process P1 is copied to physical program counter, so that this process P1 can be executed. Now again, here the CPU switches from process P1 to process P2. So what's happened here? Right now in physical program counter, the content of process P1's logical counter was there. So here the content of process P1's logical program counter is moved to its own logical program counter. So from his physical program counters to logical program counter of process P1, and now we want to execute process P2. So this process P2's logical program counter is moved to physical program counter. So right now its process P2 is executed. Now again P2 is over. Now next again it's turn for process P3. So yes, the CPU is switches from process P2 to process P3. Again same way, here this process P2's logical program counter is again moved to its own logical program counter, and process P3's logical program counter is moved to physical program counter. So in this way, whenever a CPU is switches from one process to another process, that process logical program counter is moved to physical program counter, and previous process content is moved from physical program counter to its own logical program counter. So in this way, multi-programming is to be carried out or executed. Now next move further to process model. Here there are three different figures. This one is a one program counter between each and every four process. Here each process has its own program counter, and here at a particular time one process is executed. So here in figure A, so multi-programming of four processes in a memory having only one program counter, that is one physical program counter, as we have seen in our previous slide. Figure B, that is a conceptual model of four independent sequential processes with its own flow of control. And in figure C, over a long period of time interval, all the processes have made progress, but if we see here, then at a particular time only one process is executed. So if we consider from here to here, only process A is executed. Once process A is completed, after that process B starts. Up to this portion, A, C and D is not allowed to execute, means this process will not get CPU, so this process cannot be executed. Again process B completes, then immediately process C starts. Again C complete, then process D starts. Again process D completes, then process A starts. So at a particular time only one process is executed, means each and every process is executed sequentially. So this is a process model. Thank you very much.